So sample test, review test, whatever you want to call this thing, we'll go through and do this. And again, we're going to do the evens because, again, they're doubled up questions, so if you can do number 2, you can do number 1. They're the same questions, just different variety of what's here. So we'll just kind of go down through here and do the evens on this thing. All right, so number 2 just says to factor 15c plus 20c squared. Okay. All right, again, if you've got the blue sheet that we had, or not the blue sheet, the factoring sheet that we had, it kind of breaks it down for this thing. You've got 2 terms, so the first thing you're always going to look for is the greatest common factor. So 15 and 20, you can divide them both by 5. You've got c and c squared, so you both can take a c out. And then from there, it's just, all right, you're going to tell me everything else that's left over. Take 15 divided by 5, that's 3. Took the c out. 20 divided by 5 is 4. If you take 1 of the c's out, you're left with 1 left over. So it would be 5c plus 3 plus 4c. And that would be your final answer that you're looking for there. All right, number 4. Same question, or same directions, sorry. Different question. This time you're going to 3 terms. So we got z squared plus 13z plus 12. And as long as you go to trinomials, going through a different list of things, the first term is 1, so the a term here is 1, so that's good. So for this one, all you're going to do is just find the factors of positive 12, where the sum is going to equal positive 13. The signs. So the pair that's going to add up to 13, that's going to be the 1 and 12. So then your final answer would be z plus 1 and z plus 12. Okay, number 6. Same thing on it. Still just says the factor. So it's 3x squared minus 2x minus 5. Okay, back to the 3 terms. So if you go back to the paper on the side, we've got 3 terms. The first term is not 1. It's something other than 1. So in this case, we're going to have to do the AC, or the bottoms up method. So for this one, we're going to start off by multiplying 3 times negative 5 to get negative 15. And that's the factors that we're looking for. And question? Okay, starting off with 3x squared minus 2x minus 5. We've got a trinomial. First term's not 1, so we're going to multiply the a and the c terms together to get negative 15. And then from here, we're going to find the factors then that add up to be a negative 2. All right, so for that one, there's only 2 possibilities. It's either 1 times 15 or it's 3 times 5. B term is negative, so the sign on that one goes always with the bigger number, and then divide these 2 numbers. But doing negative by negative makes the other number a positive. Okay. So to get negative 2, that's going to be the plus 3 and the minus 5. Okay, now here's where you have to go that one extra step, because the first term was something different than one we multiplied by 3. So now at the end, we're going to go back and do the same thing to even it back out. We're going to go back and divide everything by 3. Okay, and then you simplify. The 1s will cancel, these 3's will cancel to make that x plus 1. This one doesn't simplify, so then the last step then to factor it easy, pull the 3 up in front of the x. And make it 3x minus 5. Okay, question number 8. Same thing. Still just says factor for the direction, so there's nothing else other than just factor. So you get w squared minus 49. Alright, if you go back to the factoring sheet, it's only 2 terms. There's not a greatest common factor, so there's nothing you can factor out on this one. Once you get there, it has to be the difference of 2 perfect square numbers. And again, for the perfect square numbers, w squared is just w times w. 49 would be 7 times 7. And for the difference of perfect squares, well, you just put the w first in both parentheses, put the 7 at the end. So when we do the full method, you get the 7 times 7 for the 49. And since it's negative, there's only one way to get a negative number with 2 numbers. One has to be positive, and one has to be negative. And for that one, that's all that one's going to be. Okay, and with 2 terms, that's really the only 2 options you get. Either there's a greatest common factor, or it's the difference of 2 perfect squares. There's no other ways that you can factor anything with 2 terms. Okay, now there is one that pops up here with number 10. And this is one of those problems that you have to just kind of put this one back into memory, because this is one time it'll pop up, and that was pretty much about it. I don't even know if this one will actually pop up at all. I think we did talk about it, though. 8w to the third plus 27. Okay, now this one's different than all the other factorings that we did, because it is to the third power. All the factoring back here when we were doing all these with the parentheses, it was w squared. This one was x squared. This one was z squared. So on all those we were doing the trinomials was kind of on that one. This one's different because it's 8w to the third plus 27. So if you look at this, this is the sum of 2 cubes. And there was a little section we went over, there was one problem, and it was either the sum of cubes or the difference of cubes. And this one wound up being one that was a sum because of the plus in the middle. And basically, what we're going to do is this, and this is one of those where it's not really a whole lot you can do with this one other than just to plug it in the formula. And the formula for that one is that if you have a cubed plus b cubed, that's going to be not too far there. If you have a cubed plus b cubed, the formula is it's just a plus b times a squared minus ab plus b squared. All right, got that one sign right there. Okay, and all you have to do then is take these 2 numbers that you have here and break them down so that there's something cubed. 27 would be 3 to the third. And you have w to the third, but you also need an 8 with this thing. So if you take 8 and break it down, that would be 2 to the third. So that would be 2w to the third, and then plus 3 to the third. Okay, and for the formula, basically is this. Everywhere that you have a, you're going to take the a and replace it with 2w. Everywhere you would have a b, you're going to replace that with a b, with a 3. Okay, so we're going to do, and again, we've already got the a cubed and the b cubed here. So let me actually scoot that over just a little bit. So we're going to do 2w plus 3. We're going to do a squared, which would be 2w squared minus 2w times 3 plus 3 squared. Okay, and there's only a small handful of things that you can do with this one. The first parentheses there is 2w plus 3, so that one's pretty much done. For this one, you can do 2w squared and make that 4w squared. The 2w times 3, you can change that and make that minus 6w, and then 3 squared would be 9. Okay, and that would be your final answer. And again, it's one of those where it doesn't really get anything out of it. It's just, here's a formula, you plug the numbers in the formula, and then that's all you get. There's really nothing you can do on one like that. Okay, so for number 12, it says find all excluded values. And then it says that is find all values which t is undefined. Again, excluded values is really just one small thing that you have to do for excluded values. Just take the denominator and set it equal to 0. Okay, so for this one, add 6 to both sides. And then divide by the 2. Okay, question 14. Same directions on question 14. 14 is this one simple. Actually, let me go ahead and get number 13 here, because it's got one small difference with it. So we'll do that one, and we'll get to that part. All right, 13, same direction on this one, find all the excluded values. The only difference on number 13 is now you get something like this. Well, we were, but I'm going to show you this one just to be on the safe side. Occasionally you run across one that you might want to show you, so this is one. I'll show you this one. Okay, same directions on this one. Still going to find the excluded values. So you're still going to take this denominator and set it equal to 0. Only difference on this one is now your denominator, I have to factor it first. So once you get here, you got to find the factors of negative 18. Where the sum would equal positive 3. Okay, so 1 and 18, 2 and 9, and 3 and 6. Got to be the 3 and the 6. So for this one, it's just a matter of getting the signs in the correct place. Since the b term is positive, bigger term's going to have the same thing. And if you do a negative divided by positive, it makes the other number a negative. So that's a v minus 3 and a v plus 6. Okay, now in this one, once you've got it factored, here's where you're going to have to go that one extra step. That basically you're going to take whatever each parentheses that you have and set that equal to 0. So v minus 3 would equal 0, and v plus 6 would equal 0. So we get v would equal 3, and then v would equal negative 6. So if the denominator happens to not be factored completely, if it's a quadratic expression that's in the bottom, then you've got to go through and factor this thing off. On the previous one, on number 12, you had to do a little bit of factoring, but really it was just saying it equals 0 because it was just the one number there. So if you do happen to get the v squared or x squared or whatever, factor it off first and then go back and solve each parentheses equal to 0. Kind of get what you need there. All right, back on the evens here. Number 14, this one just says simply 2 Simplify. We have 24 times y minus 5, 2y minus 3, and then 6 times 2y minus 3 and y plus 2. Okay, for this one, everything is in factored form. They factored everything that they can for you. So from here, you're just going to cancel out anything that's the same. You can get rid of the 2y minus 3 that's here and the 2y minus 3 that's here. And the only other thing you can do is the y minus 5 and y minus 2. That part's pretty much done, so nothing you can do there. The only other thing that you could do is with the 24 and 6, you could divide those both by 6. And make that down to 1 and 4. Okay, because those are in parentheses, go ahead and leave the parentheses there. Now for this one, you make it 4 over 1, so you don't have to put the 1 just because it's there. So if you want to put this in the way that would be the most simplified form with the least amount of work you would have to do, then that would be the answer that you're looking for there. If you left it here, that would still be okay. But again, if you're doing 1 times anything, it doesn't really do anything, so you could just take that 1 off and leave it. You know, if you scratch that off and leave it with the y minus 2 with parentheses around it, that would still be okay. I guess kind of good news is y'all are doing this by hand and putting the answer in. So, you know, you could, just in your head, you could take that step out to get the answer from here to here. So. All right, 16. Same directions, just different question. And it's kind of like the 13 and 14 above this one. The big difference on this one is that everything is not factored out for you, so you've got to go back in and factor this one. Okay, and every time that they say simplify, you pretty much need to think that, okay, what I've got to do is that I've got to factor first and then cancel. Okay, so the whole middle section that we're doing in this part is kind of the same way. So first part was all factoring. The simplifying part really is still factoring. Just the difference is after you factor it, then you cancel out any terms. It's the same. Top part, not much you can do with it, so it's good to go. The good news on the bottom part is if you're finding the factors of negative 7 equals 6, there's only one pair to get 7. It's got to be 1 and 7. It's just a matter of getting the signs in the correct way. If the b term is negative, that means the bigger number would have to be negative, which should make the other number then positive. Okay, so you got that factored, then you can go back through and cancel out the v minus 7s, which will leave you with a v plus 1 on the bottom. And again, technically you're putting 1s in these places, so in the top you do have to put the 1 there as a placeholder. Have it be as 1 over v plus 1. All right, 18 says to multiply. And again, it's still pretty much following that same directions back here for simplifying. You're still going to factor everything first, and then you're going to go back through and cancel. So even here, it's still going to be the exact same way. You're still going to go ahead and factor everything off first, and then you go back and cancel what you can. So for this one, we're going to go with x squared minus 5x plus 6 over x squared plus 2x minus 3. And then we have 3x plus 9 over x minus 2. And again, we'll just factor everything out as much as we can for this part. With the x squared minus 5x plus 6 for that part, we're going to look for the factors. And here's where your signs have to be careful. The factors are positive 6, where the sum would equal negative 5. Because with 1 and again, with 1 and 6 and 2 and 3, you can get 5 both ways with those numbers. You just have to be careful with the signs, because it's all about where you put the signs for this one. Since the b term is negative, the bigger number is negative. If you divide a positive by negative, that also makes the other number a negative also. So in this case, they both have to be negative. So that would be the x minus 2 and the x minus 3. Okay, for the one on the bottom down here, we'll do it in green. The good news with this one is it's still the same setup, but there's only, if you're going to find the factors of 3, there's only one way you can factor. It's going to have to be 1 and 3. The b term is positive, so that means the bigger number needs to be positive. If you divide a negative 3 by a positive 3, that makes the 1 then to be negative. Okay, on the bottom, nothing you can do with x minus 2. It's pretty much done. The top, there's only one small thing you can do here. You have 3x plus 9, you can divide them both by 3. Make that 3 times x plus 3. Okay, so we factored everything as much as you can. Now you just go back and start canceling out what you're able to. Let's see, there's an x plus 3 and an x plus 3 that can go. There's an x minus 2 here and an x minus 2 here. So all together at the end, we're left with a 3 times x minus 3. And that's over x minus 1. Okay. And with number 20, it's almost the same thing. The only difference with number 20 is it tells you to divide. You're still going to factor it first. You're still going to go back and cancel. But the key thing is on divide is that before you do anything at all, really, you have to do keep, change, flip. You're going to have something like this, that you have 9x squared minus 25. That's over 2x squared plus 3x minus 14 divided by. Okay. Again, we'll go keep, change, flip here. So the 9x squared minus 25 stays where it is. 2x squared plus 3x minus 14 on the bottom. Change that to division multiplication, and then flip this thing upside down. Okay, so the first kickoff on the division problem is you've got to rewrite as multiplication, which means we're going to do keep, change, flip. And once you've done that, now it's just a multiplication problem, so then you're going to factor and then cancel. Okay, so still just more factoring, and more factoring on this thing. So for this one, again, if we do this part in blue, 9x squared minus 25 is 2 terms. They're both perfect square numbers. 9 would be 3 times 3. 25 is 5 times 5. Just make one a positive and one a negative, and that's your 2 numbers there. Okay, we'll go ahead and do the right-hand side over here just because there's not a lot to do. With 5x minus 10, you can divide those both by 5. 5 times x minus 2. The 3x plus 5 here, there's nothing you can do with that one. Okay, but we do have some work to do on the bottom over here that we'll do in grid. Okay, for that one. First term is 2. So we're going to do the AC method, start off with 2 times negative 14. So negative 28. So we're looking for the factors of negative 28. Where the sum is going to come out to be positive 3. So 1, 28, 2, and 14, 4, and 7. The only way you can get 3 from these numbers is 4 and 7. B term is positive, so we need the bigger number to be a positive to match up with the sign. And if you do a negative divided by a positive, it makes the other number a negative. In the beginning, we did multiply by 2. So we'll go back and divide by 2. 4 divided by 2 is 2, so it just becomes x minus 2. This one doesn't simplify because it's 7 over 2. So pull the 2 up in front of the x. And leave it with 2x plus 7. Okay, so factored everything as much as you can possibly factor once we change it to a multiplication problem, and now it's just all canceling. There's a 3x plus 5 that'll knock out that 3x plus 5. There's a x minus 2 that will knock out that x minus 2, so that eventually leaves us with 5 times 3x minus 5 over 2x plus 7. Okay, so simplifying, multiplying, dividing, it's still all pretty much the same thing. You factor everything as much as you can, and then after you factor everything as much as you can, then you just go back and cancel out anything that's like terms. Whatever's left over, then the leftovers is the answer that you're looking for. Okay. So that's kind of the first two things with it, because the first part was just factoring, second part was simplifying, which is really factoring and then canceling. Third part, where they kind of change gears just a little bit, is they're going to ask you to start finding the least common denominators, working with some different things on this one. Number 22 says fill in the blank. To make equivalent expressions. Which is pretty much just saying rewrite this with common denominators. It's kind of what they're saying. Okay, I think with the online homework, the way they set this up, they should give you a box that's here. The way it's written like that, it's kind of hard to see. But basically, here's a box where it says, okay, here's the answers that we've got, or find this answer that you would put in the box here. Okay, and basically is this. All you did to change it from here to here was you multiply by y minus 1. Whatever you do on the bottom, do the same thing on the top. So for this one, we're going to multiply by y minus 1. Now, the one thing I did notice on this one, that's what I was just checking, that instead of leaving the answer as 6y times y minus 1, which is what I would say to kind of do, they go ahead and do distributive property and actually multiply this thing out. So that you do 6y times y to make it 6y squared, and do 6y times 1 to make it minus 6y. Now, test question wise, that's one of those where if you leave it, here's this answer, and they want this answer, just let me know, because I'll go back and fix that. Because sometimes without knowing how the answer is supposed to be written, you don't know how to write the answer. So if you run across a question like that where you just didn't do one little thing, just let me know and I'll go back and check the points on that one and make sure that you've got full credit for something like that. Because they don't really, without being an example, you don't know which one of these two could be the answer. So really, to me, either one of those two answers would be okay. If you left it like this, that would be fine. If you actually distribute out, that would be fine too. Okay, so they go from finding common denominators or rewriting expressions to making them the same to actually having you add and subtract some numbers. And you should start off with something that has common denominators. All right, if you have common denominators, just rewrite it as one denominator and then just pull the two parts together. And once you've made it one common expression, then the denominator will just be one number. You actually have to work on the top part now, so now you just work on the top part to simplify it out. You've got 3y plus 5y, which would be 8y. 2 minus 6 is negative 4. And then they do tell you that after you add or subtract, whatever they tell you to do here, that you do need to simplify as much as possible. Okay, if you look at this one, you've got 8, 4, and 4. Well, you can divide all the numbers by 4 if you want to think about it this way. So on the top part, you can go one more step. With 8y minus 4, you could divide 4 out of both of these. So that would leave you with 2y minus 1. And again, just kind of realizing that when you get to the end, that anytime you have an expression with a plus or a minus in the middle of it, that basically it's one big parentheses where you have to have another 8y minus 4 to cancel. In this case, you can divide out of 4. So you've got 4 times 2y and you've got 4 over y. Well, in that case, you can cancel out the 4's. So that will leave you with the 2y minus 1 on top and just the y on the bottom. Okay. 26. Same thing. Still going to tell you to add. The big difference on 26 and 25, though, is that with 26, you're not going to have common denominators. So with 5 over x plus 2, and then plus 6 over x minus 1. Okay, and for least common denominator, when you start adding and subtracting, basically everything that's different, that has different parts and pieces when you factor it out, that you've got to include basically one of everything for the most part. So that's going to be the x plus 2 and then the x minus 1. do then is go back and rewrite the expression with both of those pieces with the least common denominator. Okay. With the first one, we had x plus 2. We put an extra x minus 1 in the bottom. So whatever you do on fractions, as long as they're equal and equivalent, then whatever you do on the bottom, you have to do the same thing on the top. On the second one, same thing. And an x plus 2 and x minus, already had the x minus 1 on the bottom, so we multiplied in an x plus 2. We'll have to do the same thing on the top. Now, here's one where we said we'll save just a little bit of work on this one, because once you've got a least common denominator on the bottom part, you're not really concerned about the bottom part at all. So I'll just go ahead and put LCD just because it takes out a little bit of confusion as you're going through this one. Because everything now, focus goes back to the top. You've got 5 times x minus 1 plus 6 times x plus 2. So all your focus now is on the top. Because once you've got a least common denominator, you're done with the bottom until we get to the very end and we've done all the work you can do on the top part. So go ahead and do distribute property. You've got 5 times x minus 1, make that 5x minus 5. You've got 6 times both of these, so that'd be 6x plus 12. Top part, you've got 5x plus 6x for 11x. Negative 5 plus 12 for a plus 7. And now that you've gotten that down as far as you can go, you combine like terms. There's nothing that's in common. There's no greatest common factor you can take out. Now you can bring back in that least common denominator of x plus 2 and x minus 1, and then see if there's anything that cancels. For one like this, there's nothing that cancels. So that winds up being your final answer. Okay, so getting common denominators, adding, subtracting, they're all kind of along the same line. That you're going to get the least common denominator, and whatever you do to the bottom to rewrite it, then you have to do the same thing to the top. The big difference is when you add and subtract, just make sure, and again, it's maybe something simple, but once you've gotten the least common denominator, I would just write down LCD. It does two things. One, it speeds up the process, and number two, it takes the focus off the denominator, and now you're focused on the numerator, because now that's where all the work is done. That once you've got that least common denominator, there's nothing else you can do on the bottom. It's all about the top number then. And then so you just got to work on the top and work it out as much as you possibly can. Because a lot of times people will focus on this part and they'll go, oh, I'll start canceling stuff. No. Once you get that least common denominator, you're done with it. Until the very, very, very end. Everything from now on out is your focus. It's all in the numerator, doing everything you can there. Okay, number 28 kind of spins off the least common denominator part because this is a complex fraction. Now, it doesn't say anything about it being a complex fraction. It just says to simplify. I think 27 pretty much does the same type of thing. It's another complex fraction, but just a little different wording on it, but it's still pretty much along the same lines here. That you have a 2 minus 1 over 5w over 7 plus 1 over 5w. So 27 and 28, both complex fractions, just one's a little different than the other one that goes through it. Okay, now here's where the similarities kind of come in. You've got to figure out what your least common denominator is. which for this one works out kind of nice because the only two denominators you have are 5w, so your least common denominator would be 5w. Okay, now here's where it changes. You could rewrite it with common denominator, but with complex fractions, usually the easiest thing to do then is go back and take every single number that's here and multiply by your least common denominator. Okay, and by doing that, multiplying by everything by the least common denominator, all your fractions should cancel out. Because this 5w will cancel this 5w. This 5w cancels this 5w. And you're left with, should just be all whole numbers from here. You've got 5w times 2, well that's 10w. This all cancels out and leaves the 1 that's here. 5w times 7 is a 35w. Everything cancels, left you with a 1 here. Okay. Now, and again, once you've done this one, fight the temptation because technically those two things are in parentheses, so they're two totally different expressions. So you cannot cancel anything here because they're all technically tied together. So that one thing there at the end would wind up being your final answer. Oh, yes it is. I put the wrong sign in there. Thank you. That would be a negative right there. Sorry about that. Okay, and that question kind of rolls right into the next question we'll get to there. Number 30 says solve for u. Where it starts off with it's a rational expression that you, or a rational equation that you have to solve. Now, it's still got the same similarities. You're still going to figure out what the least common denominator is, and here's where it's going to be similar to the part that was back here. Then instead of rewriting everything, we're going to go back through and multiply everything by this least common denominator. The only catch for this one is that when you start off on this one, you do need to factor everything completely first. So before you do anything at all, you've got to go back and factor everything as much as you can. The 1 over u minus 2, there's nothing you can do there. 6 over u minus 2, nothing you can do there. Actually, make that a u plus 2. Sorry. 6 over u plus 2, nothing you can do with that one. But because you have u squared minus 4 for this one, you could make that a u minus 2 and a u plus 2 because that's the difference of two perfect square terms. Okay, so factor everything as much as you can, which really is just your denominator here for this part. Then tell me what the least common denominator is, which in this case is you got a u minus 2 and a u plus 2, so it's got to be u minus 2 and then u plus 2. And just like we did in the complex fraction, this time we're going to go back and multiply everything by the least common denominator to get rid of all the fractions so that we're left with non-fractions and all the equations that we're going to do here. Okay, so what I'm going to do, just to kind of save some room, is I'm going to go back and just say we're going to multiply everything here by u minus 2 and u plus 2. So doing that, we've got the u minus 2 would cancel this u minus 2. That's going to leave us with 1 times u plus 2. On the second part of the fraction here, the second part of the expression, you've got the u plus 2's would cancel, we'll leave you with the 6, and then a u minus 2. And on the right side, the u minus 2's cancel, the u plus 2's cancel, so everything cancels here and leaves you with just 11. So distributive property to 1 doesn't change anything, it's just u plus 2. Now, again, for my help on this one, just to be on the safe side, if you remember, go back and put a 1 here, you can, just because sometimes, as you're adding, subtracting the like terms, it can help there. Go ahead and multiply everything here times 6. So we got 1u plus 2, 6u minus 12. You can do the 1u plus the 6u and make that 7u. 2 minus 12 is negative 10. Add 10 to both sides. 7u equals 21. Divide those two numbers. And we get u equals 3. Okay, so three main parts of the test so far. You've got just the factoring, where you just factor. You've got the simplifying part with a little bit of multiplication and division on either one of those. You're going to factor everything as much as you can, and then you're going to cancel everything as much as you can. And then the third part we've gotten to is where you're going to start rewriting with adding and subtracting, that you're going to basically rewrite your denominator. You're going to factor everything as much as you can. Find out what that least common denominator is, and either you're going to rewrite it, or when you get to the solving part, you're going to multiply by that least common denominator to cancel everything out. Okay, so 3 different kind of sections so far on the problems we got, and then the last few questions here, we're going to deal with all the functions, which again kind of changes gears and goes away from math more of just practice and understanding problems. That it kind of takes a hard break and change when we get to this last part. Then on 32, it's basically going to ask you for domain and range. And they're either going to give you a graph, they'll give you some ordered pairs, whatever it may be for something like this. Give you a quick sketch of a graph here. We'll go back and put the order pairs, but because this is what it may look something like here. Okay, they'll give you an X, Y axis without taking the time to pull the graph in here, because sometimes it takes too long to pull it in. They'll give you 3 or 4 points. All you've got to do is go back in and make a list of what these order pairs are. For this order pair that's up here, again, would be a lot better to tell on the test. This would be at negative 4, 3. Next order pair that's here, that would be at negative 2, negative 2. That order pair would be at negative 1, 0. And then this pair would be at 3, negative 1. Okay, so for your domain, just go back and list off the numbers, and again, it's just your x values. Order or not, it doesn't matter, as long as you got all the numbers here, that's fine. So it's negative 4, negative 2, negative 1, and 3. And for the range, 3, -2, 0, -1. And domain range, that's pretty much about it. It's just knowing that domain is your X and the range is your Y, and just pull out those individual numbers from every ordered pair that they give to you. Um, 33, we'll do it because it's a little bit different than some of the other ones. 33, this is the one where they give you all these different options and say, is this thing a function? So is the relation a function? And again, if you have repeated X values, that's no. That's the big thing that you're going for on this part when they ask you, is this group, this relation that we're looking at a function? And they can write this thing a bunch of different ways. But it just comes down to, do you have repeated X values? Okay. And they may start off with like blue, red, orange, green. Have that go to 1, 6, 3. And maybe so that you have something like that. Okay. And if they've got it drawn with domain and range like this part, we said the only thing that you're looking for is that if you have two arrows coming from the same domain range going to here, that part would make it a no. So if all you have is one line drawn from the domain to the range, doesn't matter if it's all pointing to the same range or not, as long as there's only one line from each domain value, then the answer is yes. We'll give you some numbers here. Let's say it's 2, 4, 6, 8 for the domain and 1, 3, 5, 7, 9 for the range. Okay. 6 goes with a 5. A 6 also goes with a 7. So because of that one number here, that was going to be enough. Okay. And if they give you ordered pairs, it's just as easy, because on the ordered pairs, you don't have to worry about the arrows. You just go back and look at the X values, and if you have the same X that shows up 2 or more times, it's a no. If it's each individual X is different, then it's going to wind up being yes. Okay, 34. This is one that Susan was talking about earlier with the graphs, where they give you about 6 or 8 graphs and say, does the graph represent a function? And that's where you're just going to use a vertical line test. Go back and draw a vertical line through it. If you hit it once, you're good. If you can hit any point on the line, or if you hit 2 points or more on graph that they give to you, then it's not going to be. It may be something like this. Again, they'll just scatter some dots around. And all you're doing is, if you have dots stacked on top of each other, if you can draw a vertical line through those 2 points and hit it 2 more times, makes it enough. You know, if you had it spread out where the points were all over the place and none of them were stacked on top of each other, something like that, that no matter where you drew a vertical line, you're only going to hit 1 point, and that was okay. And then after that, they'll just give you random, you know, they'll give you someone some points on it. After that, they just give you random shapes, and they'll just say, all right, here you go. Is that thing a function? Well, draw a line right through here, hit it twice. That's enough. Here's another function. Draw this line. Is that what a function? It's good, right? Because no matter how many times you draw any vertical line through here, you're only going to hit it 1 time. If the vertical line gets a little crooked there. That was yes. That's all you got to do on those. Okay, and then the last few pieces at the end, still kind of dealing with functions, having you work through some of these, that they'll give you different functions to start off with. This one we'll go with 36 here. F of x is negative 3x minus 3, g of x is negative 2x to the third minus 3. And they're going to tell you to find a couple of different values here. They have to find f of 7 and g of negative 2. So with 2 different numbers, just means you've got 2 different values to plug in. For this one, everywhere you have an x, you're going to take out the x and replace it with 7. So over here, the same thing. Take out the x and replace it with 7. Everything else around it stays the same, so it's negative 3 times negative 7, which is 21. And 21 minus 3 would be 18. Okay, so for f of the negative, they should give you f of 7, they should give you the equals. Just go back and put in the 18 for this part. And again, you don't do anything else to this part over here with f of 7 because that's like the notation, that's your directions. It's just simply everything that's on the right-hand side. Question, Dave? Did I put something? Oh, sorry. It would be negative 21. Sorry about that. I was thinking that was a negative 7. I was already looking at the next problem over here. Yeah, so negative 21 times minus 3, that would be a negative 24. Thank you for catching that. There we go. Thank you. Yeah, I flashed over to the G part of it and was seeing the negative and was already thinking that part there. Okay, same thing on the G part now. Make sure I keep my signs correct here. Everywhere you have an X, you're going to take the X out and replace it with a negative 2. So over here, we'll do the same thing. Take out the X and replace it with a negative 2. And this one's in parentheses, so when you plug it back in, just like we did here, put that number in parentheses. so that you know that that number has to be just like it. Everything else has to be on the outside. The negative 2 is on the outside, the cubed is on the outside, that minus 3 is on the outside. Okay, from here it's just order of operations. You got to do the negative 2 to the third power first. So negative 2 times negative 2 times negative 2 would make that out to be a negative 8. So then you have negative 2 times negative 8, which is a positive 16. And 16 minus 3 is 13. Okay. I think the only other thing they could do on one like that was they may give you, one function and give you a chart, and you just go back and fill in 4 or 5 of the same values, but it's still just that same thing, and just plugging in numbers and just kind of working out. Okay, 37, 38, and 39. These are all word problems. And again, they're going to blah, 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 blah. They give you an equation in the middle of it, or a function in this case. And for 38, your function is b of x equals $15 minus basically 9 cents x. And they tell you that this is it's a photo center where you have to pay $15 up front, and then every photo that you copy is 9 cents afterwards. Okay, so B is how much you have remaining with everything. So then they come back and tell you, all right, here's everything that you're doing for everything that's on this, and they tell you that X is equal to the prints. And they come back and say, all right, well, what's the balance after he has 20 prints? Okay, so they told you that X was the prints. So what's the balance after 20 prints? Just take out the X and replace it with 20. And then from there, you just work out the rest of the equation. Again, because you plugged in that number, go ahead and put it in parentheses, and in this case, you're going to do 0.09 times that. 0.09 times 20 should be $1.80. Subtract those two numbers, and that should be $13.20. Okay, and the only thing they do different on number 39, same word problem, they set you up with an equation. One time they'll ask you, if he spends this much money, how much more can he have on prints? Where you just take the equation and work it back around. The other time is they'll do the same thing as this one. They say, all right, if he makes, so many prints, how much money does he have left over in his balance? So they kind of go back and forth on the two questions. And basically it comes down to, one time you're going to put a number in here, and then you're going to solve this thing for X, and the other time you're going to put a number here, and then just work this part of it out. So it's still the exact same thing. It's a word problem, but they give you an equation in the middle of it, and everything you're going to do is going to spin off of that equation, and they're going to give you some value to plug into it and just work it out from there. Okay, number 40. If I can draw this one a little bit better here. You have a graph that's something like this. where you got a definite beginning and ending point. And they're going to ask you to write the domain and range in interval notation. Okay, and this was one that we looked at last time because we talked about domain and range, and then all of a sudden they sneak one in on you where they talk about interval notation, and they just kind of drop that in on you from left field, and we had to go back and figure out, exactly what they were talking about with interval notation. And basically, here's what it came down to. For your domain, you have to tell me what's the leftmost point all the way to the right-hand point. So start with the leftmost point on the graph, go to the rightmost point on that one, and then when you talk about it, just tell me what the x value is in the leftmost point, and tell me what the x value is in the rightmost point. Okay, so the point farthest to the left would be over here. Now I do need to give you some numbers so you can actually see what this is. If you went back and found this point on the graph with the grids, it would be at -4, -5. And this point would be at 3, 2. Okay, so the point farthest to the left is -4, -5. So tell me what the leftmost point is. Well, that's at -4. The right-hand point is at 3, 2, so tell me the next value. That's going to be at 3. Okay, and all you're going to do is you're going to put a comma in the middle. Now, here's where they kind of tied in the thing with the graphs when you graph these way back when. If you have a solid circle, use a square bracket around it. If the point you're talking about is an open circle, then you use parentheses. Okay, and then for range, I'll come back to that graph here in just a second. Start with the lowest point, and then you run to the highest point. And whenever you talk about the range, because you're going up and down, you're talking about the y values. Okay, so for this graph, again, your low point's right here at -4, -5, so now you're going to use the y values. So you're going to start at -5. That one was a solid circle, so we'll box that in. The high point was over here at 3, 2. We're going to use that y value of 2. And because it was an open circle, then we use parentheses. Okay, so the biggest thing on that one is when you pull the graphs off, you have to kind of just separate the two, and you're going from left to right. And when you do that, you only look at the x values. The leftmost point, tell me what the x value is. Look at the rightmost point, tell me what that x value is. When you talk about range, that's your y value, so now you're moving up and down. So tell me the lowest point on the graph, tell me that y value. Go to the highest point, tell me what that y value is, and then kind of go from there. Okay, now, and sometimes depending on what the graph that they give to you, it may be just kind of flashing back here. It could be a graph that's like this, where that you've got, high point. Basically, you got like a tie for the high point. If that's the case, then there should be, they should be marked. If there's 2 points that's a tie for a high point or left point or right point or something like that, they won't give you one that's open and one that's solid. If that was the case for a problem like this, where you could kind of go either way, they would make both of these an open circle so that you could tell, okay, it doesn't matter which one I pick. They're both the high point, so whether I pick either one of those, then the value would be the same. So if there happens to be a tie between 2 points, they should be exactly the same, either solid or open when it comes down to it. Okay, and then the last 2 questions. 42 is doing basically the same thing that we did back here on, let's say 38. Really, it's the same thing as 36. The only thing that's different on 42 is that the problem is just a little bit more complicated looking. but it's still the same thing. They give you some function. And they'll still come back to tell you, okay, tell me what g of 8 is. Look, same setup as the earlier problem. That all you're going to do is you're going to take out the x. Everywhere you have an x, put an 8 in its place. And then everything else around it, you're just going to go back and work in all those pieces. Okay, if it's a fraction, really you're treating it like two different problems. You got to simplify the top part, simplify the bottom part, and then come back and see what you get. Bottom part really quick and easy. 8 plus 6, that's 14. Nothing you can do there. Top part, a little bit more work because you've got more parts to it, more terms in the top part. So 8 squared is 64. 8 times 10 is 80 plus 9. 64 minus 80 is negative 16. Plus 9 would make that be negative 7 over 14. And that one you could simplify down to make it negative 1/2. And again, there's 2 or 3 different questions that they all look a little bit different, but they're all still the same thing. You know, here's some function, here's a number, plug it in and just work it out and see what answer you get. We'll show you this one. Number 43 is a little bit different because this one gives you a function. And instead of giving you some number to plug in for this function, this one it says find the values that are not in the domain. Okay, and all that means, this is the same thing we were doing in the earlier part when it said list excluded values. It's the exact same thing, they just call it something different here. That earlier they talked about doing excluded value. This one's the exact same thing. They just worded it a different way. So when it says find the values not in the domain, that's the same thing as saying excluded values. So it's the same difference on this part. You're going to take whatever your denominator is and just set it equal to 0. So whether they say find the values not in the domain or list excluded values, either one of those that they tell you to, basically that just means you take your denominator and you set it equal to 0. Okay, for this one though, because it is a little bit more complicated, denominator means you have to go that little bit extra step, which I think we did one like this earlier too. No, we did. You still have to factor this thing off. Well, that is 2 perfect square numbers. Maybe like, well, you know, how are we getting that from here? Well, 1 is still just 1 times 1. So when you factor this one, it's going to be x plus 1 and x minus 1. Okay, and then set both of those equal to 0. Real quick, we're going to get answers of positive 1 and negative 1. Okay, and then the last problem on the review. back to the multiple choice where you get 6 different problems and it says, is this thing linear or not? Okay, let's see if y'all remember. If you've got x equals 4xy minus 5, is that linear or not? Not, because, great, if you've got x times y multiplied together, it's not. X over 4, 4y over 5 equals 6. Yeah, I mean, just look at your notes, right? Yeah, there's no, now you've got x's and y's, but they're not in the denominator. There's nothing multiplied together. They're all first power. So, linear or not? Yep, it is. Good to go. So as long as you got that list in front of you, you just look on the list and go from there. 4y equals 8, or negative 8. Good, right? There's no x times y. There's no variables in the denominator. There's no powers bigger than 1, so yeah, we're just good to go. And then the last one. Nine x plus 7 plus 6y equals y minus 4. Same thing, nothing in the denominators. No variables in the denominators. There's no x times y. Everything's to the first power. Yeah, so we're good to go.